Okay, we are going to learn science chapter sound. Okay? Okay. First of all, you understand the sound very easily. Even you are talking, it's called sound from our throttle. Okay, which is inside our neck area. It's also come when produce the sound, and it's also come when you are going to hear sound by ears, right? So this is very easy that this is the sound. Everywhere is sound, right? Even you want to say anything, you want to understand anything, sound is there. Okay, so but this is not kind of that simple. Might you don't have raise any question, but I'm telling you the question, like why sound, any noise, transfer one place to another place? How and why? You know that? I'm telling you right now. Okay? If you are sitting in front of me, okay? Not even front of me, like 2 blocks away. So even I can say louder and you can able to understand it. You can able to hear it. Why? With what help the sound traveling with one place to another place? Have you ever think that? Yes or no? Next question I'm asking you, that why the sound rising and become low? Why low sound cannot hear, and why loud sound can hear easily? Okay, next thing, in the universe there are many stars or many heavenly bodies, it's called celestial bodies, are crashed to each other. Then why we are not hearing that sound? And the last question is, how sound is produced? Produce mean how sound is created. So these are the question, and whatever in your mind, it's not like a theory basic, you just give me the answer. It's not like that. You can give me also example and explain me whatever in your mind. You can tell me this answer. Okay, I don't need any sophisticated answer, which is written in the notebook or textbook. No, whatever you think, just give me the answer. Give me the answer back. Okay? Okay, let's start chapter sound. Okay, first of all, sound is what? Yesterday, you gave the answers, which is some kind of experiment or practically that you may realize about the sound. But now we are going to learn some thoroughly. Thoroughly means deeply. What could be the perfect answer of these all questions? Okay, first of all, sound travel from one place to another, of course by medium. It require medium. Okay, some said air, require air to pass, right? Even in a water, right? Even the room is closed, but after concrete wall you can also somehow sound heard, right? You listen the sound, some noise or some voice, right? So it's required medium, but not always air. There is other medium also, like water, okay, also some kind of solid object. So from there also noise can be passed. Okay, so how the noise can pass? First of all, I'm giving one example that this is a speaker, okay, and the sound produced from this. If you know your earphone, or you can say headphone, if it's broken, then open that speaker area, and there is a kind of this diaphragm. It's called diaphragm. It's like a little thin one. So from this vibration come, and just because of this, it's can be make noise very properly. Okay, it's called diaphragm. It will come in the next standard or another studies. Okay, so when the sound passes, this is like a sound happen. Okay, so this the sound molecules. Now you know what is the molecule, small particles in the air, right? So from the help of the molecules, or you can say through the molecules, sound wave passing through the one place to another place. This is kind we understood in a simple way, but what in the science language we are going to say, because in this chapter there are many new words you will understand. It's just called the science, it's just called the perfect science, okay, like that. So in the science way, this is the waveform. It's called waveform of the sound wave. This waveform is called sine wave. What? Sine wave. You will see this sine wave in 10th standard. Sine wave, and even it comes in the maths too. Okay. So this is the wave of sound. It passes through what? It is passes through the air molecules to one place to another place. Okay, so this is the basic information of the sound. So let's see the definition of the sound. Okay, sound is what? Wave. Wave comes from where? All right. Without you plug in your phone, or without charging your battery, I'm talking about cell phone, or you plug in your tape recorder or CD player or MP3 player, you cannot hear the voice, whatever you apply on cassette, CD, or any kind of player, right? So it's require charges has electrons means what? Energy, right? So whatever sound passes, it's require energy. Even you also, without energy you cannot even walk one place to another place, right? As well as same, sound is an energy, right? Energy which is passes one place to another place with the help of the molecules. But molecules, what molecules do? If energy passes through somewhere, it's going to be sound, and it's going to be vibrate. Okay, so vibration in what? The particular pattern. This is the pattern, right? So from the base of this, first of all, what? It's energy produced, and it passes through the air molecules. And what air molecules do? Air molecules do vibrate. Okay, vibration in particular pattern. Okay, this is called waves. Particular patterns, it's called waves. Okay, so let's see the definition whole. Sound is form of energy. Sorry, not from, form. Sound is form of energy that produced when air molecules vibrate in particular pattern called wave, and it is sound. Okay, Here is some example that I'm giving you. First is guitar. There are different kinds of instrument, different kinds that even you are doing something with pen. This is also sound. This sound with what? I'm slamming this pen to the page. But this is a kind of effect on molecules, and this molecule's energy passing to me with the air molecules, and I can hear in my ear like that. Okay, so first is guitar. Guitar, you know, the guitar, it plays and make a sound with the help of the string, right? So string motion, yes, it's a little bit motion, but if you see with closure, you can see the motion of the string that make a noise or make a sound, right? So vibration and motion of what? Vibration and motion of string. It could be asked in a blank and MCQ, right? Vibrate and motion. Okay, next is drum. Okay, drum what? Vibrate with a by heat stick. Okay, it's called membrane vibrate. Membrane vibrate means what? This is kind of space that occupied in a drum. Okay, and it's membrane vibrate. Like you, if you see this, some kind of portion is vibrate even after hit the stick. It's called membrane vibrate, right? So here are some instrument that make a noise or sound with the help of the string, with the help of wind blowing by our mouth or somewhere else also, right? Then next is percussion. What? Percussion. Okay, string instruments are guitar, violin, cello. Okay, then wind with blowing with mouth like flute, trumpet, bagpipe. You can search and see the photos of it. And the striking hit the stick, right? Like drum, xylophone, bell. Okay, so this is the example of the instrument that make a sound or a noise with the help of the string, wind, and percussion of striking, right? So this is the basic of the sound. Now let's see deeply on it, how it make. Okay, let's see now importance about sound. Okay, so sound cannot generate without vibration. Okay, without vibration sound cannot generate. All right, first thing, vibration is comes somewhere as a friction also, you know that. For example, I'm telling you the friction it about aeroplane. Yeah, so if you watch the video of aeroplane with very closely, that the fans of airplane which is vibrate like this. Okay, why? Because it hits with the air molecule and that also vibrate, and that's why the friction comes, and because of the vibration sound or noise produce, right? So basically it would be asked in your test or exam that without what sound cannot produce. Then without vibration sound cannot produce. Okay, and sound carried by what? Sound carried means what? It carried in the sense that traveling to one place to another place, it's called carried. right? So carried by medium. Medium is required. Without medium, sound cannot pass or cannot travel one to here to there or anywhere, right? So first is without vibration sound cannot be produced, and sound can be carried by what? Medium. Okay, now next important, sound cannot travel in vacuum. Sound cannot travel in vacuum. Okay, so in a vacuum means what? I'm talking about space. Okay, from the space some meteoroids or some comet comes. I'm not talking about comes toward the earth. I'm talking about it would be moves or travel anywhere, right? So it could be friction. Okay, it could be travel, but even two star is going to be crushed to each other, mixed to each other, right? So that is like a huge explosion, but we cannot hear that, right? Because it is in the vacuum, right? So in a vacuum, what is meaning of vacuum? There is no air, it's called vacuum. If it's air, then there is no require any space suit. There is no require any space suit to go in the in a rocket and the space station with oxygen cylinder, right? So there is no air. So because of there is no air, vibration cannot be generated, and there is no molecule, so it cannot travel one place to another. Okay, it means what? Sound cannot travel in the vacuum. Okay, clear? Now let's see what is in the sound. Okay, so sound is not that some voice comes and we hear. Not only that, we are going more deeply. Okay, let's see. Wave and particle motion of waves. Okay, wave, what kind of wave that we see here, but what is in the wave we are going to understand. Okay, first, this wave is depend on what? Medium. It has to be required medium. Yes. Motion, direction of motion. Motion is what? Vibration. Vibrate like this. This is also called motion, right? If it's travel, then it could be go further, but the motion is there. Okay, vibration of something. Even your speaker is going to be vibrate if you if you full your volume of TV or somewhere, touch the speaker of the TV, you feel the vibration. This is also called one type of motion. This motion is periodically means what? You know that like this is one object, or you can say ball, go this way, then this way, and then come again in this way. So this is one kind of periodically motion, right? So this is go like this. It is also called motion, and as considered as a vibration, it's fine. So it's a required medium. Okay, then and direction of motion. This too, medium and direction of motion, is called wave propagation. What is that? Medium, direction of motion, it's called wave propagation. Propagation means what? It's moving somewhere, yes. With the help of what? With the help of medium. And it's traveling, as we see here, traveling. Okay, so this is the term is called wave propagation. Okay, now you may raise the question, what is the medium? Okay, what is the wave? What is inside the wave? It is energy, yes, but we will see that what kind of energy in it, why it's called wave. So this is all comes in the sound wave. Okay, there are many waves you heard about: electromagnetic wave, electron wave, you know, magnetic waves, like that. You understood in 13 chapter, might be in the last year, right, about EM waves. So everywhere, whatever you understand about the science, I'm talking about engineering science, not that biology and all, planting and all. So waves in there. Okay. So we have to learn what is the wave. Right. So before we start the wave, let's understand what is medium. Why require medium and what is the medium? Okay. Before that, let's see. I'm giving the example of radio. Okay. You heard the radio. There is no require any wire connection. No. You just turn on the channel like 98.3, 91.1, 93.5. Right? You just set the channel and the music goes on. Songs goes on. Why? Why? There is no any connection. Even you don't know where is that office of this station, 98.3, where is that office and you are connected from that. No, you don't know anything. But though you get all the sounds, you get all the signals from there. Why? This signals is like this waveform. We cannot see this waveform because our eye cannot able to that level. Okay, there are some in the gigahertz, you know that gigahertz, right? So it's G means what, MB, GB, it's megabyte, kilobyte, you know that. If you recharge your card, that you know that your internet is remaining like this, you know, it's like a giga. It's all the waveform, and it's all the energy which is travel. So this energy travels through the air molecules. Okay, everywhere from the antenna. Okay, and you have a little an antenna in your phone. Your backside is called back strip antenna, and from base of that you catch the signal of the radio and you can hear all the songs by converting that energy into the sound energy. So this is the medium. Even you cannot see the medium, but it is the medium, like air. This is the best example of medium is radio that I explained now, right? So the matter or material, one kind of molecule is also material, right? So matter or material through which sound propagate means what? This one, direction, motion, travel. Propagates means what? Travel. Okay, traveling, energy or wave. Okay, it's called medium. The matter or material through, from which, from what matter or material sound will travel, it's called medium. Okay. Okay, here we understood about the medium. I'm giving uh, uh, the example medium for the communication. Okay, so this is medium which is energy converting electrical and also converting the sound energy, right? So there is a diaphragm is also used, and the uh, different circuit, you can say, it is also inside of it to convert. Okay, so converting electrical to sound or somewhere else also transforming. Okay, so let's see the types of wave. Okay, so first of all, you know the wave we understood in the uh, before video. Now here is the wave which is transverse wave and longitudinal wave. Okay, transverse wave means what? Transverse means what? Situated and extended. Okay, it's called transverse. Extended is a synonyms of transverse. Extended about what? It is travel perpendicular. Okay, so particle motion is to perpendicular to the direction of wave motion. Okay, so this is the definition of the transverse wave. Okay, particle motion of particle motion is to perpendicular to the direction of the wave motion. Okay, this is the wave. Okay, and this is the reference line, you can say 0. Okay, and here is another wave. Okay, so the wave, if these are the points, or you can say the particle motion which is perpendicular to the direction of the wave motion. This is the direction, right? Here is frequency f. So the perpendicular direction of the wave motion, it's called transverse wave. This is the types of wave. We are not going to thoroughly in it, but you just need to understand the definition. The particle of the motion, particles which are perpendicular to the direction. Okay, it's called transverse wave. Okay, here is the example, which is light. Light can transverse, extended with perpendicularly. If you know the laser, okay, some particular highlighter, you can see it, right? And this transfer wave is also called mechanical wave. This transfer wave is also called the mechanical wave. Okay, nowadays the LED also comes like that, with the higher energy of the level of the energy in it, which is some kind of similar to the laser, if you know that, right? So this is the transverse wave. Particles motion is to perpendicular to the direction of the wave motion. Alright, now let's see the another one, which is longitudinal wave. It is parallelly travel. Okay, I'm giving this some simple example of it. You know the slinky, right? You go another side. If you force another side, it goes another side. Then opposite sides, like slinky, like that, like a big spring. You know. So this is parallelly travel the energy and with the sound, right? If you just force right side, it is like a wave, continuously wave travel to the another side. If you know that, even your uh, childhood time you could play that, right? So this is the traveling parallelly, one by one by one by one, like this, like this. It transferred here, like this. It's called slinky. So this is called longitudinal waves. Okay, then what is that? The particles of the medium travel parallelly to the direction of the waveform. Here is particle travel perpendicular. Travel, you can say, or also you can say motion is also fine. Motion is also one kind of travel. This is some kind of synonyms that we are using, right? So when particles of medium travel parallel to the direction of the wave motion, parallelly travel particles with respect to the direction. Okay, so it's called longitudinal and transverse wave. This is also called rarefaction or compression. Compression is what? shrinking. So you don't need to require more energy. For the another example I'm giving, you just throw the stone or paddle in a pond or lake. You just thrown on a one direction and the one space occupied. There is only little space, but its waveform travel like this in the pond or lake. So this is kind of wave. Okay, so this is parallelly travel, right? All right. Now next see more in the waveform, which is amplitude, time period, and frequency. This amplitude, time period, and frequency, this is the mean value of wave. Mean value means what? The minimum, okay, the least wave we just examined and understood how it is work. Okay, so from the base of that we are going to understand amplitude, time period, and frequency. This is comes by the mean value of wave. This is the mean value of wave. It could be asked in a MCQ also. Okay, first see amplitude. Okay, amplitude is defined capital A. Okay, so what is amplitude? The number of molecules that a sound wave displace means what? Travel, motion. Also another term is displace. It's okay. Okay, from the mean position to max position due to the vibration. Mean position to max position. Mean means minimum, right? So minimum here is 0. We take a reference as a 0. Even in your if you when you draw the graph, you took the 0 as a reference and then you measure or plot the values, right? So the mean value is this 0 and max value is this. So from the 0 to the max value, mean value is not should be 0. It could be in a minus integers also are there. For here you can see it could be here is minus 5 and here is plus 5. Okay, so the amplitude mean to max, which is 0 to plus 5, so it is called the amplitude. Okay, so position of the sound wave, which is mean to max, it's called amplitude. Okay, as you can see here, this is the amplitude. This is max plus 5 and this is mean plus 5, right, with respect to the reference, which is 0. Okay, now next see time period. Okay, time period means what? It's a duration with particular time, specific time. Okay, so what is that? The time taken for complete oscillation. Now new word comes oscillation. What is meaning of oscillation? Movement between 2 points, as I told you, like this. This is the 2 points and movement like this. This is kind of vibration and this is also called the oscillation, right? So the time taken for the complete the oscillation means what? There is a 2 point that molecule travel first then second, again first then second, right? So this is the time period. Sound wave is called the time period. Okay, let's understand with the diagram. Okay, so it is I'm talking about the two portion in this waveform. Okay, so here is the starting waveform. Okay, it starts from here, goes max, then goes min, and then again comes to the 0. Okay, so this is the one time period if you consider as a with the starting point to ending point. Okay, so starting point max then also comes in 0, but there is another point which is mean point, and then comes to the 0. So this is also called the time period, right? Next time period is what? Talking about max value or peak value. You can say the peak value. Okay, this the peak value like this. Consider as a plus 5. The peak value. So peak from one peak to another peak. So started from here and ending up to here. So this starting to ending of between 2 points, right? So this is called the oscillation, and on what time it's might be 1 second, it might be 0.5 second. So this period of the time, it's called time period. How much time taken to travel molecule from peak to peak, from starting to ending. Okay, so this is called the time period. Okay, now next see the frequency. Very important. Without frequency we cannot able to do anything about the communication, right? You communication as well as in telephone, video, live chat, FaceTime, whatever. Okay, so frequency is must, right? So let's understand the frequency basic. The number of oscillation, it's called time period, right? The number of oscillation an object takes per second. So how many time period take place in 1 second? Okay, to understand the frequency you must know what is the time period, right? So what is the frequency? Time period. What is that? The oscillation. An object, the number of oscillation, vibration, or you can say moment, like peak to peak or starting to ending, with respect to reference. Let's make here 0 so you can able to more understand, right? So the number of oscillation an object takes per second. Okay, so per second how many time period or how many waveforms peak to peak, then peak to peak in 1 second. So that's called the frequency, right? Let's understand more about that. Before that, let's see the SI unit is frequency is hertz, because hertz discovered the frequency, right? And its unit is like H and prefix is Z. Hz, it's called hertz. Okay, so in a simple way you can say 1 hertz is equal to 1 oscillation per second. 1 oscillation and 1 time period per second. Okay, so we can understand more with the low frequency and high frequency. What is that? Okay, so low frequency and high frequency, you can easily make the difference that here is the waveform with some more space. This is called wavelength. Okay, we will see it later. And here is the waveforms but little or short wavelength with small length. This is the length. Okay, now you can imagine that in 1 second, okay, for the reference I'm telling you for the 5 second. Just imagine in 5 seconds these are the waveform goes faster. Yes, okay, that's why it's called high frequency. In 2 seconds this waveform comes from here, start to ending. There are so many waveforms covered in the 1 second, right? But that's why it's called high frequency. But here in low frequency, from the 1 second, how many waveform, if you consider the peak, there are only 2 peak considered in a 1 second. But in the 1 second high frequency, there are how many peaks? 6-7 peaks. So that's why it's called high frequency, and that's why it's called low frequency. And this is the time period we are talking about. Like low frequency, it is require long wavelength. That distance is more. It's called wavelength. Okay. And the short wavelength is like little like this. So it's here is what? Oscillation or time period is more. That frequency is fast, traveling. But here is frequency traveling but slowly. So this is called low frequency. So this is the base on the time period. Okay. But now we are also understand what wavelength. This is the wavelength. This is the long wavelength and this is short wavelength. This is the amplitude A. This is the wavelength. And from starting to ending, it's called time period. Okay, let's see the wavelength. The distance between successive crests of the wave. The crest. Starting point 0 to 0. Okay, so it's called, here is the start and here is the stop. Okay, so distance between that crests, it's called wavelength. Okay, it's unit like this, lambda. It's called lambda, but this is for the standard, not for now, but for the information. Okay, so the distance between successive means what? It's actually travel practically. It's called successive crest. So the distance between that 2 points horizontally, not vertically, it's called wavelength. Okay, so this is the basic of the sound we learned today. Okay, if you have any questions from this all video, then please ask. Okay, thank you.